Hi everyone, welcome back to our YouTube channel, Becoming a ROS Developer. So today we have one of our students, Sean, who has just completed the course ROS Basics using Python, and he is going to be giving us a demonstration of his project. So I'll just hand over the floor to him so that he can start doing his presentation. Alright Sean, over to you.
All right, thank you. So first I will teleop to an appropriate place so I can start the wall following. So what this is going to do is it's going to find the nearest point in a service. It's going to invoke a service, and it's going to find the nearest laser scan, the closest laser scan from the 720 lasers going around the robot, and then it will move towards that, and then it will turn again to do right-hand wall following. Then it'll do right-hand wall following, giving feedback through an action. And actually, I'm going to start over here and get away from these obstacles. And then it will and then when it reaches within where its starting point, after it does a lap, it'll return all the odometry points, and then I control C it and it quits. So let me try there. So let me do ROS to launch.
Sean, would you mind showing your terminal? Let me see.
So it's right now it's turning, then it goes towards the nearest point in a range.
Hi Sean, you can hear me, right?
Yeah, I can hear you.
All right. I think. Let me just see if it's visible here. Okay. Yeah, you can go ahead.
Okay. So now it did its service. So it found the nearest point. It turned towards it, it moved towards it, and then it did right-hand wall following. So it aligned to its right-hand side. And now it's doing um, wall following. And if I go here, see it has distance, so it's gone about a meter or so.
Do you mind if I ask you to pause right there a little bit?
You want me to control C?
No, I just pause your presentation. You can leave it doing whatever it's doing. I just want to see if I can capture it properly.
You want me to pause what?
Just pause your presentation. You can leave the robot moving around. I just want to
Just stop sharing?
no, it's fine. Leave it sharing like that.
Okay.
All right.
And then when it returns to its starting point, it stops giving the distance because it drops out of the while loop
All right.
that it's in right now in the action. Yeah, so these are the odoms. And that's it. And so I can show you my code.
All All right, all right. You can go ahead. Yes.
So it's pretty much broken up into three parts. So I did a custom interface for both the. So here's my custom interface for my action. And I did the CMake list and the package. I updated that and used the suggested. You had to modify it a little bit from the suggestions in the basic instructions, but this is what it looks like. And then I have my wall following server. So same thing. And then in wall following, this is what does all the, so I have my main file is wall following, and it subscribes to laser and it publishes to command vel, and then it also creates the service client call and the action with send goal and the feedback. For the wall following, I just did this down here in a timer callback. I did message twist, and then I have with flags because it was kind of basic. I have if self, so if the distance in front is less than half a meter, then I turn left because we're doing right hand wall following. And then while it's moving, if the distance to the right goes too far to one side or the other, then it adjusts appropriately with its angular.z, and then it publishes. So that's wall following. So for the service, the initial service that found the closest point and then turned towards it and then did right hand, then aligned its right hand side to it. This is in here. So here in the laser scan callback, so I have a re-entrant callback callback group with a multi-threaded executor in the main to run both these threads at the same time continuously. And it blocks the wall following until it's done. And this is laser scan callback. So I have it was 180 degrees off from the sim to real, the simulation to the real robot was 180 degrees off with 720 lasers. So I took the min and then I found the index of the min. So I called that self.iterator or self.it. And then I had a simple state machine down here, which is looking for the range of that iterator. So when it's the closest, I had better luck with this than doing uh, trying to do radians or degrees and trying to find that with sim to real. So
Okay.
what I did was I have a range of the minimum iterator that it finds, the minimum distance from the lasers, and that position, I find the range and I rotate until that's called within that range. And then so that would be state one. And then it moves towards the wall until it's 0.28 meters from the wall. And then it does the right hand wall following. Again, it continues in state three, turning until it's within range of the right hand of the robot. And then it stops the robot. And then it returns response, found wall. And then it goes back to wall following where it does the wall following. And then I have my odometry. And in here, um, I'm I'm subscribing to odometry, and then I have an odom callback. Same thing as the service. It's re-entrant callback group. Um, and then I have in here I take the well, first I make a point from the first position. And while I'm um, not far enough away from that point to start recording feedback, I just sleep. I just wait. And then once I'm far enough away, but I'm not back to the original point from doing a lap,
Mm-hmm.
then I do basically the hypotenuse of a triangle from the XY positions and and update that in total distance and then return that as feedback to my wall following. Um, and then once it reaches the close to the original point where it started, it'll get out of the loop, out of this while loop, and it will return the list of odoms as XY values, and that'll go back to wall following and print out on the console.
All right, all right. Anything else?
No, that's all. That's all I did. It took me a while, but I did it.
All right, all right, all right. It's good, good. I like the use of um, states, right? It makes it easier to um, manage the whatever is coming from the laser scan there.
Yeah, it made it easier to debug and everything.
All right, all right. So I'm gonna ask you a couple of questions to just get some clarity on how you did it. You spoke about using re-entrant callback groups. Can you please explain a little bit more what's behind that choice? Why re-entrant callback groups?
Um, because it worked primarily, it it um it allowed the threads, multi-threads, to run at the same time.
All right,
And
all
so
right,
I could, and so it wasn't working before, and so I got it to work that way.
all right, all right. So you saying you wanted them to run concurrently. You wanted to run multiple threads.
Right. And I wanted to block the wall following program until it returned, until the last thread ran on my wall finder.
All right. So you're trying to ensure that one precondition is met before you take the robot takes the next step.
Right.
All right. All right. I see that. I see. All right. So and then you spoke about using some form of calculations for odometry, like using calculating the hypotenuse of the triangle. Can you take us through that? Were you trying to measure how far the robot is from the beginning, or you're trying to measure the
No,
furthest thread?
yeah. So while it's so far from the beginning, then I take a smaller triangle hypotenuse
Mm-hmm.
um, from the last odom dot x to the last recorded x
Okay. So
that
you
I do up.
you're like doing your own custom odometry, sort of, right? Keeping track of how far it is from the beginning.
Yes, and then I'm updating the distance from a smaller triangle
Ah, I see.
from XY.
I see. I see. Okay. Okay. That's quite good. That's quite good. All right. So how far did you manage to get to the beginning in terms of accuracy? Did you get to the original beginning, or you had to wait until you ran
No,
out
I
of
could
space?
only get down to about 10 centimeters.
All right.
I know it said about 5 centimeters, but when I ran it a few times in simulation,
Mm-hmm.
I was having trouble reaching the exact point when it goes around in its lap
All
because
right.
it kind of bows out from the wall a little bit
All right.
at some points.
All right. All right. I see. I see. I see. Let me see if I have any other questions here. I see you also have a test script. Can you give me a rundown of what were your main test parameters to just prove if your code was doing what you want?
That was kind of to save it. I was doing flags at the time instead of a state machine,
Okay.
and and that was just to save what I was doing in wall following before I butcher the main file.
All right, all right, all right, all right.
And
So,
I also have a copy. So
mhm.
I have copies.
So you did a copy using a different method using plugs, and then you went back to state machines.
Yeah, I went back to State Machine because it was working a lot better. It wasn't and it was simpler. It was easier to comprehend.
Yeah, very. It in terms of simplicity, yes, very good. I quite like that myself. Can you also elaborate on uh, what could you presume to be the reason for the offset that you found with your laser scan, right? Why was it 180 degrees out of your initial presumed accuracy?
I assume that it was like that because on the simulated robot, it scans left and it goes. I just tested it out, you know, and it goes from 0 to 719 lasers,
Mm-hmm,
and
mm-hmm.
0 is in front of it, but because of the cord on the real robot that blocks some of the lasers, and because it's more difficult at 0 to 719, that jump to they just had to pick a spot to put the cord basically. And so I think they did that so that, you know, 360 is now in front of the robot.
I
I'm not
see.
sure though.
I see. I see. All right. All right. Yeah, but a very nice observation right there. Very and a very good way of dealing with it also. Uh, yeah. All right. Do I have any other questions? No, not anymore. I would say well done, Sean. I quite like the way you did it, particularly handling laser scan data. I think I've said that again. So yeah, you have made it, and we'll wrap it up here, and then we can finish our meeting in Zoom. Okay, so I'll just wrap up our stream, and then we can talk later.
Okay.
All right. All right, everyone. So this was Sean's presentation, and if you would like to also do a presentation of the courses that we do offer, you're welcome. So until next time, keep pushing your ROS learning. Bye bye.